All right, so today we're diving deep, deep into the world of ferrofluid.
Ferrofluid.
Yeah. It's that liquid metal stuff, right, that just seems to, like, defy gravity when you put a magnet near it.
Oh, right, right. It's stuff that makes those crazy spike shapes.
Exactly. And we've got a whole bunch of listener-submitted factoids here about this almost magical substance.
Let's hear 'em.
Okay, so apparently it's a magnetic liquid that moves. And it's made of, get this, nanomagnets.
Nanomagnet.
Yeah, suspended in oil.
Interesting.
And it gets even weirder. Apparently, it was initially developed by, wait for it, NASA.
NASA, what for?
To control rocket fuel in space.
Wow.
I know, right? Plus, now it's finding its way into all these, like, modern medicine applications for targeted drug delivery.
No way.
Yeah. And it even helps create leak-proof seals in electronics.
That's wild. So where do we even begin with this stuff?
Well, I guess the first thing we got to do is unpack just what makes ferrofluid, well, ferrofluid. I mean, what exactly are we dealing with here?
Right. I mean, it's like 1 minute it's flowing like any normal liquid. The next it's forming these like solid, spiky structures.
Exactly. So, like, at the microscopic level, what's going on?
Okay, so basically, ferrofluid is made up of these teeny tiny magnetic particles, nanoscale we're talking, and they're suspended in a carrier fluid.
And that's usually oil, right?
Exactly. Oil's the usual suspect. And these nanoparticles, the nanomagnets, as you called them, they're constantly just jiggling around.
Jiggling, why?
It's called Brownian motion.
Oh, right. Like random movement of particles.
You got it. And it's super important in ferrofluid because it keeps those nanoparticles from all settling at the bottom or clumping together.
Because they're all attracted to each other.
Exactly. It's like a constant dance party, keeping those nanomagnets from turning into one big magnetic blob.
I love that analogy. So, wait, but how do they actually stay suspended? Like, is there something else going on?
Oh, yeah, good point. We also throw in some surfactants.
Surfactants, that's it. Like soap, right?
Kind of. Think of them as little bouncers, keeping those nanoparticles from getting too friendly. They coat each particle, creating a barrier so they don't stick together permanently.
So it's like a balancing act.
Yeah. You've got the magnetic forces pulling them together, but then the surfactants pushing them apart. It's that balance that gives ferrofluid its uniqueness.
Gotcha. So then what happens when you bring a magnet into the mix?
That's when things get really interesting. You get those crazy shapes.
The spikes.
Exactly. So as you bring a magnet close by, those tiny particles, they all try to line up with the magnetic field lines. And because there are so many of them packed together, that alignment, it actually has enough force to, like, change the shape of the liquid surface.
Oh, so each spike we see, it's actually like tons of those nanomagnets all working together.
You got it. And the stronger the magnet, the crazier the shapes get.
That's amazing. And I think this whole thing started with NASA.
Yeah, back in the 60s, they were trying to figure out how to deal with liquids in space, with no gravity.
Because, like, pumps and stuff rely on gravity to work, right?
Exactly. So they were looking for other ways to move fluids around, specifically rocket fuel.
And they thought, hey, let's make the fuel magnetic.
Yeah, pretty much. They thought ferrofluid could be the answer. Use magnetic fields to control it all.
So, did it work? Did we ever get magnetic rockets?
Well, it was a great idea, but in the end, it turned out to be a bit trickier than they thought. Making a stable magnetic fuel, well, let's just say it wasn't easy.
Too bad. But hey, at least ferrofluid found other uses, right? Like in medicine and electronics, you said.
You're right, it did. Even though it wasn't meant for rockets, it definitely got people thinking. Especially in the medical field.
Yeah, you mentioned something about targeted drug delivery.
Right. The idea is to use magnets to basically steer medicine to exactly where it's needed in the body.
Hold on, so they, like, inject ferrofluid into people?
Not exactly. They attach the drug to those tiny ferrofluid particles.
Oh, I see. And then use magnets outside the body to guide them?
Exactly. It's still early days, but it has huge potential. Think about treating a tumor, for example, without harming the surrounding healthy tissue.
Wow. That's incredible. It's like
Right.
sci-fi come to life.
Yeah.
So what about the electronics applications?
Oh, right. Ferrofluid is really good at making leak-proof seals, especially in devices with moving parts.
Like what?
Like hard drives.
Hard drives.
Yeah. You see, they have these spinning disks inside.
Right.
And they're super sensitive to dust or anything getting in. So you can use ferrofluid and magnets to create a liquid seal around the spinning parts. No leaks whatsoever.
So it's like a liquid O-ring. That's really clever. So we've got potential rocket fuel, life-saving medicine, and better hard drives, all thanks to ferrofluid. But I still don't get how it actually works. Like, what's happening at the, atomic level that gives it those weird properties?
Well, it all boils down to this interplay between, well, a lot of things actually, magnetism, obviously, but also fluid dynamics, surface tension, all playing a role. But the real key is understanding magnetic domains.
Magnetic domains. Okay, now you've lost me. What are those?
Okay, so imagine each of those little nanomagnets, right? Each one is like a tiny bar magnet with a north and a south pole.
All right, got it.
But inside those nanoparticles, things aren't so organized. The magnetic poles of all the atoms, they're all jumbled up, pointing in random directions.
Okay.
And so those areas where the atoms are pointing in the same direction, those are the magnetic domains.
So each nanoparticle is like a bunch of these tiny little magnets all pointing different ways.
Exactly. And because it's so random, the nanoparticle as a whole, it doesn't act very magnetic.
But then you bring a bigger magnet near it.
Exactly. Now, that external magnetic field comes in, and suddenly all those magnetic domains, they want to line up with the field.
So they all start pointing the same way.
Bingo. And because all the nanoparticles are doing this at the same time, it creates a powerful magnetic force that's strong enough to actually change the shape of the liquid, hence the spikes.
So the stronger the magnet, the more aligned they get, and the bigger the spikes.
Precisely. Pretty cool, huh?
Yeah, that is really cool.
Yeah.
But wait, if they're all lining up like that, why don't they all just clump together into one solid blob?
Remember those bouncers we talked about? The surfactants?
Yeah, right.
They're still hard at work, keeping those particles from getting too close and sticking together permanently. It's a delicate balance.
Like a constant push and pull, right?
Yeah.
The magnets want them to stick together. The surfactants are trying to keep them apart.
Exactly. And don't forget about surface tension, too. That plays a part in shaping those spikes as well.
Wow, so many things going on at once. Magnetism, fluid dynamics, surface tension, those surfactants. It's amazing that ferrofluid even works at all.
Right. And the craziest part is we've been studying this stuff for decades, but we're still figuring it out. All those forces at work create some pretty unpredictable and mesmerizing patterns.
Like it has a mind of its own. So we've gone from space to the microscopic world of atoms.
And we've only just scratched the surface.
I was going to say, what else is there to learn about this crazy liquid?
Well, next, we're going to move from the lab to the art studio.
Wait, art. Ferrofluid is used in art.
Oh, yeah. Get ready for some seriously mind-bending creativity. We're going to talk about how ferrofluid has captured the imaginations of artists and designers all over the world.
I got to see art studio, huh?
Uh,
I got to admit, I'm having a little trouble picturing ferrofluid as like an art supply.
I get it. It does seem a bit unconventional, but trust me, there's a whole world of ferrofluid art out there.
So, like, what are we talking about? Paintings? Sculptures?
Well, it's not really about using it as paint or a sculpted material. It's more about the, how should I put it? The movement.
The movement.
Yeah, ferrofluid is dynamic, it's
Okay.
constantly changing, flowing, and artists, they've figured out how to use that to their advantage.
I can see that. Even just watching videos of ferrofluid reacting to a magnet, it's like hypnotic almost.
Exactly, and that's what makes it so cool for art. It's like a living sculpture. Artists are using it to create these kinetic sculptures, installations, even performances.
So it's like the artwork itself is in motion.
You got it. Sometimes it's a closed system, like imagine ferrofluid suspended in a clear liquid, and then controlled magnetic fields make it move around, forming shapes.
Oh, wow.
Other artists, they'll actually let the viewer manipulate the magnets, so you can interact with the ferrofluid, change how it moves.
That's awesome. So you're not just looking at the art, you're part of it.
Yeah.
That's really cool. Are there any, like, famous ferrofluid artists? I'm trying to get a picture of what this looks like.
Yeah, for sure. There's this artist, Sachiko Kodama. She does some really amazing work with ferrofluid. She suspends it in clear containers so you can see those shapes it makes.
Wait, are those the ones that kind of look like flowers? I think I've seen those online. They're always moving.
Those are probably hers. She's known for these big installations. It looks like the ferrofluid is defying gravity. Really beautiful stuff.
I need to check that out. Oh, what about those lamps? You know, the ones where the ferrofluid forms like blobs inside a clear container. Those are pretty cool. Is that art too, or just a cool gadget?
It's kind of both, honestly. I mean, they're lamps, so they're functional, but the way the ferrofluid moves, it's totally artistic, too.
Yeah, it's mesmerizing to watch.
Mm-hmm.
I guess the possibilities are pretty much endless, huh?
Pretty much. People are using it in all sorts of creative ways. I even saw some fashion designers using ferrofluid in their clothes.
What? Magnetic clothes?
Yeah, imagine a dress that, like, shimmers and changes shape as you move.
Oh, whoa, that's next level fashion.
Yeah.
So we've got space exploration, medicine, electronics, and now art. Is there anything ferrofluid can't do?
Haha. It's pretty versatile stuff. I think it really highlights how science and art can, like, come together.
Yeah, and you're right. It does make you think differently about those two worlds. Like, they're not so separate after all.
Exactly. Ferrofluid makes you appreciate both the science and the beauty. And remember how we talked about it blurring the lines between liquid and solid? Well, it kind of does that with science and art too, don't you think?
That's a good point. It's constantly changing, surprising us. So, for our listeners who are like, okay, this ferrofluid art sounds awesome, but how do I even begin to understand it? What would you say is the most important thing to keep in mind?
Hmm, that's a good question. I think the biggest takeaway is that beauty can be found in the most unexpected places. Who would have thought that this weird liquid born in a lab could inspire so much art?
That's true. It's like a reminder to always be open to new possibilities. I
Yeah,
like that.
exactly. And that pushing boundaries can lead to amazing things. Ferrofluid art really proves that.
Okay, so I'm sold on ferrofluid art, but there's one thing I'm still kind of stuck on. Remember when we talked about all those nanomagnets?
Yeah.
Just there's so many of them, right? I'm talking, yeah.
Trillions and trillions. Yeah. It's almost impossible to grasp.
So each of those like spikes we see, those patterns, it's the result of all those tiny magnets working together.
Yeah. It's like an incredibly complex dance happening at a scale that's hard to even imagine.
It blows my mind.
It really shows you how complex things can be, even when they look simple on the surface.
And how important it is to like look at things at different levels, from the big picture down to the tiniest details.
Absolutely. Okay, so we've covered space travel, medicine, electronics, art. What else could there possibly be to say about ferrofluid?
Wait, there's more?
Oh, yeah. As awesome as it is, ferrofluid does have its limitations. Practical stuff we need to consider.
Really? Limitations. I thought this stuff was like magic.
It is pretty cool, but one thing is, it's super sensitive to temperature.
Oh,
Yeah, if it gets too hot, the oil evaporates and the particles, they all clump together.
so it's not indestructible. What else?
It can also oxidize, which means if it's exposed to air for too long, the iron nanoparticles can rust.
Okay, so you got to be careful with it. Gotcha. But it still sounds like it has huge potential.
Definitely. I mean, we're still learning new things about it all the time. Who knows what kind of crazy applications we'll come up with next? Sensors, actuators, maybe even new types of medicine.
It's like we're only just beginning to tap into its power.
Exactly. And that's what makes it so exciting.
It's crazy to think we started with NASA and rocket fuel, and now we're talking about art and tiny magnets dancing around.
I know, right? It just shows you how unpredictable science can be. And ferrofluid, this stuff is full of surprises.
Yeah, and it's interesting because we've talked about how sensitive it is, like the temperature, the air, all that. But then it can also be used in these applications that need crazy precision, like delivering medicine to a single spot in the body. So how does that work? How can something be so sensitive but also so precise?
It's a good question. And honestly, it's that sensitivity that makes the precision possible. Think about it. If we can control those magnetic fields really carefully, we can move the ferrofluid wherever we want it to go.
So like with the drug delivery, the magnets guide those nanoparticles to exactly the right spot.
Exactly. Of course, we have to make sure the ferrofluid doesn't, evaporate or rust along the way. That's where the challenge is.
So it's like finding that sweet spot where you're using the sensitivity to your advantage, but also keeping it stable.
You got it. And that's what researchers are working on, figuring out how to overcome those challenges so we can use ferrofluid for even more amazing things.
That makes sense. It's a trade-off, but with a huge potential payoff.
Yeah.
We're just scratching the surface here.
Absolutely. I mean, who knows what the future holds? New types of sensors, maybe even micro-robots powered by ferrofluid. It's an exciting time to be in this field.
It really is. And to think, it all started with this weird liquid that looks like, I don't know, liquid metal or something.
Yeah, and who would have thought it would lead to all of this?
So listeners, if you're fascinated by ferrofluid, you're definitely not alone. Keep those questions coming, keep exploring, and maybe you'll be the one to discover the next big thing.
And in the meantime, do yourselves a favor and look up some videos of ferrofluid in action. Trust me, you won't regret it.
It's seriously mesmerizing.
Yeah.
All right, that's a wrap for today's deep dive into the world of ferrofluid.
Thanks for joining us.
Until next time, keep those minds curious and those imaginations running wild.